Hello everyone, my name is Yasser Al-Mashad. I work for F5 as a security specialist. In today's session, we will cover modern applications inside Kubernetes, how to publish these applications, how to secure access to those, and finally, how to monitor them. So the demo will be as the following. First, we will deploy a demo application inside Kubernetes. Next, we will install NGINX Plus based Ingress Controller that we will use in the step 3 to publish this application to the outside world. And the fourth, we will secure access to this application using the NGINX App Protect web application firewall, which we will integrate inside the Ingress controller. And finally, to monitor the health of the Ingress controller and the application using Prometheus and Grafana. So with that, let's get started. Now, the first thing is that we will deploy our test application, which is Arcadia application. And that will create an application that consists of 4 containers and it will expose 4 services. So they are in the container creating states for now, and in a few seconds it should be up and running. And there should be also 4 services. Now, these applications can be accessed only while we're sitting inside the cluster, but they are not exposed yet to the world, so nobody can access them from outside the cluster. So let's try that while we are sitting inside the cluster. All right, so it's worked fine, so all good. Next step is to publish this application. And in order to do that, we need first to install the Ingress controller. So we're going to use the NGINX Plus Ingress controller. I'm going to use Helm Package Manager to install the NGINX Plus. So first thing that I need to add the repository for NGINX to my Helm. And the next is to execute the Helm command to install it. So I'm going to use this. Now, technically, the only required line here is the first one. Everything else are optional. But if you just execute this first one, it will go ahead and install the community-free NGINX Ingress Controller. However, we want to use NGINX Plus for a couple of reasons. First, because there is advanced features in the NGINX Plus Ingress Controller, like health monitorings, load balancing, advanced traffic manipulations, etc. And the second, we want to use the NGINX App Protect WAF inside the Ingress Controller, and this will require NGINX Plus. All right. And of course, I need to point to my private repository for NGINX Plus Ingress Controller, and I'm using the official F5 repository here. And I need this key to access this repository, which you can generate through an evaluation license or by contacting the F5 sales. And I'm going to use some of the new preview features. So I need to enable this option in order to unlock these features. And finally, I'm going to expose the NGINX Plus metrics for Prometheus so we can use it for the monitoring later in this demo. All right, so let me take that and apply. So it looks good. Let me list that. Everything looks good. So let me check the deployment, and my Ingress controller is working fine. Now the next step is that to publish now the resources, the application using Ingress resources of that NGINX controller that we just installed. And for that, let me go inside my Ingress resources directory. Now, there are 2 types of Ingress resources. There is the Kubernetes native Ingress resources, and then there is the CRD or custom resource definition Ingress resources. The Kubernetes Ingress resources are basic standard Kubernetes documented properly by Kubernetes. Everybody can use those. The syntax is the same everywhere. However, the problem with this type of Ingress resources is that they are very limited in the functionality. You can only just publish the application and do very little in terms of traffic management. However, the CRD or the advanced is allowing us to expose many of the advanced capability of the NGINX Plus inside the Ingress resources. We actually will try both of them. So let's take a look at the basic Ingress resources. You can tell this is the standard of Kubernetes by looking at the API, and the object type here is Ingress. All what it does really is match the traffic based on this host, and then it maps you a path to a service. For example, for a slash, it will go to the main, and for a slash files, it will go to the backend, and so on. So let me apply this. All right. Now, try to access my application. And you can see now the application is accessible. If I try to log in to this application, now everything is working fine. All right. And just to show you that without the Ingress controller resources, if I just delete that again, I will not be able to access this application. Basically, my traffic will arrive to the cluster, but the Ingress controller have no idea what to do with it next. All right. Okay, now let's go to the advanced Ingress controller. This is using the CRD or custom resource definition. All right. You can tell that by looking at the API. So this is the NGINX custom API. The object type here is the virtual server. Let me comment out these policies. We're going to use them in the next part of the demo for the security. Okay, now let me highlight a couple of advanced features on the CRD-based custom Ingress resources. One of those is that the advanced health monitor checks. We have the capability to do advanced monitoring like this one. So for application 3, I enable the health monitor by accessing this /status page using these thresholds, and the expected response is 200. So as long as I'm getting 200 while I'm accessing this page, I'll mark this application or this service as healthy, up and running. Otherwise, I will mark it down. Now, for your information, this health monitor will fail on purpose. So actually, this page does not exist, and we're doing that for a demo purpose. The next feature that I want to demonstrate here is that the ability to manipulate the error response codes. So for example, for app 3, all right, if the app 3 return a response code of 502, which we know it would because it will fail the health monitor, what we do here is that instead of sending the 502 response error to the user browsers, instead we're going to redirect them to the f5.com website. This can be also like redirecting them to a maintenance page or custom error page. And finally, this section is going to demonstrate some of the advanced capabilities in modifying requests and headers. So for a /test, I'm going to proxy that to the main service. But proxy means that forward the traffic to the main service, but with some ability to modify requests and responses. So these are the section for modifying the request. I'm modifying this header with this value toward the backend service, and then back from the service to the user browser, I'm adding this response header. So I'm adding my custom HTTP header with the value of NGINX school, and then I'm hiding some headers, I'm ignoring some headers, passing some headers, and then finally, I'm rewriting this URL /test to just a slash toward to the user. All right, so now let me apply this. And test. All right, so now let me refresh this again. Now everything is good. Let me try to test some of the feature that we added there. So we'll go to access the /test URL and see if the response header and request headers manipulation happened. So just access that test. We look at the request itself. We zoom in a little bit. And if you look at the response header here, there you go, we can see that custom response header that I have injected. So the traffic manipulation of both requests and responses are happening. Next, let me try to access now the app 3, which we know that it failed the health monitor. It will return 502, but instead we instructed to redirect us to the f5.com page instead. So, which is happening as well. So far, so good. All right. Now, the next step of the demo is to secure this application using NGINX App Protect WAF. All right, and for that, let's take a look at our policy. So I actually have three simple policy. The first one is the simplest one. It's just the ACL-based policy. So this is the ability to restrict access to my application based on the client source IP addresses. We can allow or deny access based on the IP address. The second one is to do rate limiting. So basically, we can do rate limiting for users access based on the source IP or even based on URLs. And we can apply this policy either globally or maybe per path or per URL. So we have flexibility here. And the third one and the most important one is the WAF policy. All right. So this WAF policy is basically going to apply a policy named my WAF policy, which exists in the default namespace. Let's actually take a look at this WAF policy itself. So this is my WAF policy, and this is the policy settings. This is where you configure the violations and the signatures, etc. So this is a very simple WAF policy. It can grow much more than that. And this is the logging settings. I'm basically logging only the illegal request. All right, so let's now apply all of them. And let's validate if everything is fine. So as long as it shows me the valid, which means everything is good, the syntax is good. And finally, let me reference them back to my Ingress controller resources. And let me apply it. All right, so now let me test it. So let's try to, let me try to trigger our WAF policy by simulating some of basic cross-site scripting attack. So let me. There you go. So this work, and you can see this is the blocking page. You can actually take a look at the logs. Let me say logs dash dev. And here you go. You can see this is the logs. It shows that this is a cross-site scripting. Now this is not the best user-friendly way to look at the violation logs. So it's better to send these logs to the remote syslog servers like or same solution like Splunk or Elasticsearch. Now, the last part of this demo is to monitor the health. So we already configured, we already deployed NGINX Ingress Controller to expose the metrics to Prometheus, and Prometheus is configured to collect those. And then we also configured Grafana to collect these metrics from Prometheus and then visualize it and display dashboards about it. So let me access my Grafana. All right, so we have a couple of dashboards here. The first one is for Ingress Controller, and this one is basically showing us the statistics about the Ingress Controller itself, statistics about the requests or connections, some of the config reads, writes, and some compute resources for the Ingress Controller. There are also another optional dashboards, so I'm using this one to monitor the compute resources for all my applications inside the cluster, including the Ingress controller. So you can look at some of the memory usage for each one of these containers or each one of these pods, some networking statistics, etc. And one of the other also dashboards that I have here is a pod specific resources. So we can go to the Ingress controller pod specifically, and we can monitor the health for that Ingress controller pod, like requested, received and transmitted bytes, bandwidth statistics, packet statistics, errors, if any. And with that, this concludes my presentation. Thank you for watching.